Hello everyone. So today let's solve the problem V this one PSPS 4PS actually, right? So let's see what PS actually mean. Yeah. So this was asked in the Codeforces round 994 for the division 2, right? So yep. You can just go through the question. It's easier to understand. I'll just summarize the question so that it will be easier for us to solve the problem. Yeah. So just give me a second. 1 second here. Yeah. So now let's see what the question states here, man. Yep. So given a string s, we have been given a string s of length n of length n, right? Containing the characters p, s, and dot. Yeah. So this is what ps, ps, ps. They have mentioned this one, right? So that is the reason they have mentioned the question like this. Given a string s of length n containing the characters p, comma s, and followed by the dot, right? So this is fine, I believe. We need to determine if there exists a permutation, if there exists a permutation p1 to pn, permutation p1 to pn uh, of 1 to n, of 1 to n, right? Of 1 to n, satisfying for each I if s of I is equivalent to the p, right? If string is there, right? If string s of I is equivalent to the value p, right? So then the prefix p1 to pi is the permutation of 1 to I. Then the prefix, this one, p1 to pi is the permutation of 1 to I, is the permutation of 1 to I. Yep. And if s of I is equivalent to s, then the suffix p1 to pn is the permutation of 1 to n minus I plus 1, right? And the suffix of s of I, so this one, this is prefix p of I that we considered. Then suffix of si, if it is equivalent to the s, actually string s, then the suffix, let me write it in this way, pi to pn actually, pi to pn suffix. So this one prefix we are considering p1 to pi, suffix will start with the pi itself, right? Pi to pn, so is a permutation of 1 to n minus I plus 1, 1 to n minus I plus 1, 1 to n minus I plus 1. Yeah. So we have to output as if such a permutation exists, right? So we have to output as if such permutation exists. Otherwise we have to print no. Otherwise we have to print no, right? So this is the question mainly. So let me read the question out loud. Just listen to this carefully. Yep. So given a string s here, given a string s of length n containing the characters p, s as well as the dots here, right? So we need to determine if there exists a permutation. We need to determine whether if exists a permutation p1 to pn, p1 to pn actually of 1 to n satisfying for each I, right? If s of I is equivalent to the p, this condition, if s of I string of this one I, if it is equivalent to the this one p, right? Prefix, then the prefix p1 to pi is the permutation of 1 to I, 1 to I, this part. Then the suffix pi to pn, suffix starts from the pi, right? Prefix ends at the pi, suffix starts from the pi. Then the suffix pi to pn is the permutation of 1 to n minus I plus 1, 1 to n minus I plus 1, this part, suffix part. Yeah. Now we have to output yes only if such a permutation exists. Otherwise we have to output no. Otherwise we have to output no. So this is the question, man. Yeah. Now I hope it's clear. Simple one, right? So let's come to the this one input output part basically. Yeah. So let's come to the input output part. So here we have been given n and s actually. Yeah. So this is nothing but the n, right? This is nothing but the n. We have 9 if you can count this one actually. Yeah. We have 9. So this is nothing but the uh, s basically. Yeah. S dot s4 s dot sp. So we have total 9 actually. 4, 5, 6, 7, 8, 9. 9 inputs we have, right? So this is nothing but the n. So this is nothing but the string actually. For s dot sp, you can count here 1, 2, 3, 4. So this is nothing but again this one string actually 6, 1, 2, 3, 4, 5, 6. You can count along with the dot actually. You have to count 5. So you can count there will be 5 p's here. Same goes with every input. Total we have 9 inputs, right? And so the output, we need to return the output in the format this one yes or no. So we have to get yes no followed by double S, double no, S no, S, right? So this is fine, I believe. Easier one. So now we have the idea of the idea on the question actually, and also the this one input output. Let's do one thing. Let's quickly discuss the complex this one approach followed by the complexities, and then let's write the code. Yeah. So let's let's consider the first example itself for this one. Let's consider first example itself. Yeah. So the approach So the approach that we'll be going with here is conflict check actually. Just remember this one. This is one of the graph matchings, this one question actually. Graph matchings question. We'll just go with a conflict check here. This is enough to solve this particular problem, man. So this is rated around 1300. Yeah, we can just go with a conflict check. Let's see what we will do actually. Let's hop into the approach part here. So let's discuss the idea first. Yeah, let's discuss the idea part first. So what's the idea here? If there exists p, right, if there exists p actually somewhere before the last position, yeah, just listen to this carefully. If there exists p actually somewhere before the last position, and there exists s, and there exists s as well, string s, somewhere after the position, before the last position, this one we can consider this one prefix, and s somewhere after the first position, yeah, suffix part, the requirements conflict and no valid permutation exist, right? In that case we have to go with the no. In that case we have to go with the no. Again, let me read this one out loudly, so just listen to this carefully. If there exists a p somewhere before the last position, and there exists s somewhere after the last position, so this one before last position, yeah, so this one before last position, if there exists a p before last position, and if there exists s actually after first position, after first position, right, after first position, then the requirements conflict here and no valid permutation exists, right? So answer will be no. Otherwise, we will be going with the answer S. So otherwise, we will be going with the answer S. So this is the idea, right? Very simple one actually, right? Let's try to implement the same thing on by considering the example one here. So we have n equals this one. What do we call? N equals 4, and so let's consider this first example actually. Yeah, first one means first input, first input among the 9 inputs that we have. So let's consider here n equals 4 here, and this one, what do we call? This one is string, right? String, we have 4 s dot sp actually. Yeah, this is fine. So first step here, we will check for any p in the indices 0 to n minus 2. 0 to n minus 2, that is from position 1 to n minus 1, right, in one based actually. Yep. Here characters at indices 0 to 2 are s dot s. Characters from this one 0 to 2 we are checking, right? As I've said, we will be checking from 0 to n minus 2, right? So the characters at indices 0 to 2 are s dot s. So here no p is found. From 0 to 2 we have only s dot s, right? Here from 0 to 2 no p is found, right? So a here in this case a is false. A here in this case a is false, right? So this is fine. Just listen to me carefully. We will check for s in the indices 1 to n minus 1. Now we have successfully checked for the p. Now we have to check for any s in the indices 1 to n minus 1, that is from the indices 1 to 3, right? So from 1 to 3 if you consider, so this is 0, this is 1 actually dot, so this is 2, and this is 3. We are checking from 1 to 3, right? So 1 to 3 we have dot s and p. 1 to 3 we have dot s, this one, this is from 1 to 3, right? We have dot sp, right? So here s is found at the index 2. So here see s is present at the index 2, right? 1 to 3 we are checking, so s is present at the index 2. So b equals true here. So b we will be going with a true. A is false. From 0 to 2 this one p is not found, so a equals false. From 1 to 3 s is present, so in this case we will be going with a true, right? Since here a and b, since a and b both are false actually, so false and true, this one false and true we will be going with, right? False and true, either if either of them are false, then it is false itself, right? So both has to be true if we want to consider this one true, right? If either of them are false, then we'll be going with a false as well. So a is false here, a and b we are considering both here, so this one will lead to false actually. A and b is this one false, false and true, right? So here in this case we will be printing yes actually, right? So we will be printing s, right? In the question, before last position and after last position if it is found. So here this one, then we have to print no, else we have to print s, right? So we have checked for the false, this one, this it is before last position and after last position, after this one first position it is not found. In that case we have to print s. In that case we have to print s actually. Yeah. So in this case we have to print s, meaning no conflict here, right? So there is no early p forcing prefix constraints while also having an s that forces a conflicting this one suffix constraint, right? So in this case we have to print s. We have to print s accordingly with the approach. Yeah. So this is how we got s. So I have shown you the first one actually. You can just check for the other 8, right? You can just check for next 1 or 2 and then you can just move on. So this is the idea and this is what we will be doing. So this is what the approach states actually. This is the approach that we'll be going with mainly. Yep. I hope the approach part is completely clear, man. Now let's do one thing. Let's quickly discuss the complexities part. As we are completely familiar with the approach, so the output that we got here is h s actually, which is equivalent to the output that they have mentioned for the example 1 or the input 1 within the question. So our approach works absolutely correct here in this case, right? As we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity here? The time complexity would lead to big of n. So why it is big of n per test case actually? So each string scanned each string will be scanned at most twice actually, right? So overall it would lead to big of sum of n for all the test cases. So we can just go with a big of n, right? So this will be the time complexity. So what will be the space complexity? The space complexity would lead to big of 1. Space complexity would lead to big of 1. uh, so here we'll be going with a big of 1 extra space. So we'll be ignoring the input storage here. Only we'll be making use of only few boolean and the integer variables, right? So overall space complexity would lead to big of 1. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n and big of 1 respectively. This is related to the graph matching. So this is fine. Big of n and big of 1 respectively. Now, as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. Yeah, so we'll be making use of the first input and the output. So let me import here input output package. Yeah, now let me go with the class name main. You can just give any name that's relevant to the question, right? So now let me go with the main method here. Remove this. Also, let me include here throws input output exception. Yeah, so this is fine. So within the main method, first thing is let's go with the buffered reader, print writer, and the this one t that we have given actually, right? We have to read the number of test cases here. 9 test cases we have, right? So this is fine. I'll just go with buffered this one reader br equals new buffered reader new input stream reader. So this is fine. I'll just go with the system dot in. So this is fine. The next one is let me go with the print writer here. Uh, let me go with the out equals new print writer of system dot out actually. So yeah, this is fine, man. Now let's do one thing. Yeah, we also have to read all the test cases, right? I'll just go with the integer. We have to pass, right? Uh, pass int actually. Then we are going with the buffered reader. So let me go with the buffered reader dot read line here. This is fine. We are just reading the number of test cases. We are done with the input output part. Now we have to loop over all the test cases. So let me make use of the while loop here. If it is greater than 0, then the first step that we need to do is we have to read n, nothing but the length of the string here. We have been first we considered here n equals to 4. This example we considered n was 4 actually, right? We have to read the n. Here the same thing actually, integer dot pass, and so this one let me copy. Let me paste it over here, right? So this is fine. Yep. So the next step here would be we have to read the string s as well. Yep. So just below the n, we have been given s here, s dot sp, this part within the input one or the example one. Yeah. So this one also we have to read. I'll just go with string s equals just buffered reader dot read line. Yeah, this is fine. The next part would be uh, let's consider two boolean values, man, a and b, right? A equals if found this one, if we have found the p in the position 0 to n minus 2, b equals if we have found the this one s in the positions 1 to 3. So that's what we did. That is the idea basically, right? Yeah, so I'll just go with a boolean a equals false initially, also b equals false as well, a and b both. Let's set this one to the false initially. So this one, let me make this one small b, man. So yeah, this is fine. Next, what we'll do, let's go with the two for loops here. So I'll just go with for I equals 0, I less than n minus 1. So let me go with I plus plus. So this is fine. If I'll just go with s dot caret. So this one I'll just go with I. If it is equivalent to the p, then let me assign a to then let me assign a to true actually. So this is fine. This phenomenon. Yeah. So this is fine. So let me copy the same thing and make the necessary changes for the this one. So did I miss anything here? If s dot mm, I is equivalent to the p, let me close this one parenthesis over here actually. Let me copy the same thing here. So instead of this one actually, so we have to start from 1 to 3, right? So this one will be I equals 1. Instead of n minus 1, let me consider this one n, just n, and I plus plus. This remains same. If s dot caret of I, if it is equivalent to s rather than the b, so then we have to set the b to true. Then we have to set the b to true, right? So this is fine. So that's what we discussed in the approach. The final step here is if both are found. If both are found, then it is impossible. Else it is possible, right? So I'll just write here out dot println if both are found. See, if A and B, if both are found, then if it is impossible, right? So then we have to print no, else we have to print right? Else we have to print right? So yep, this is it. Next, we are done with the logical part. We are left with only one part, that is, we have to flush the output buffer, right? So I'll just go with out.flush, or you can just close the output as well by making use of out.close. Both works. Yep. So this is it for the this one code actually. Simple one, right? So this one. So this is rated around 1300. This is fine. After many days, we are solving some medium based or this one easy or medium based question. Yeah. So this is fine. Now, before checking the code with the different inputs, let me copy paste the signature starter template. Just give me a second here. I'll just come and I'll paste it over. So this is fine, man. Yep. So now I'll just come to the question. Let me copy this one. The output we need to get here is let's check the same thing. So let me hit the run button. We are getting S no followed by double S. S no followed by double S. This is fine. Then double no, yes, no, S, right? Double no, yes, no, S. Yes, we are getting the proper output, right? So let me copy this one entirely. Let me hit the submit code button here. So let me select here B, right? BS 4 times. Yeah, let me hit the submit button. I hope this works for all the test cases, man. Yeah, this is the simple one. I won't lie. Let's wait for some time. Let me reload this one once. This shows accepted here, but it still shows here running on the test one actually. Let's wait for some time. Or let me reload this one again. Yeah, here the verdict that we got here is accepted, meaning whatever the code that we have written works absolutely correct for all the test cases. Yeah, see, so we went with a simple conflict checking this one approach for this one. Yeah, so this problem is based on the graph this one matching actually. So yeah, so this is fine, man. This is one of the simple ones actually. Yep, this is fine. Now I hope the solution part is completely clear along with the approach and the complexities. For now, This is it. Thanks for watching, guys.